Okay, welcome to the lab for this section of the lecture. And just before we jump into the lab, here is the table for the lecture content on effect sizes with those interpretation guidelines cleaned up for you. So use this when you are interpreting the effect size statistic for these different effect size stats. And now to the lab, we'll pick back up where we were on forecasting. And I'm going to show you two methods of forecasting. One is kind of simple and linear, and the other would be exponential smoothing. And so to show you this, we're going to go to this Excel sheet. And this Excel sheet is a section from a Statistics Canada table on crop production. So you'll be familiar with this. We've worked with similar data in previous labs. But what I've done is I've only downloaded canola crop production for Saskatchewan. And let's say the policy issue I'm dealing with is that I want to set a goal for the province in terms of crop production. Canola has been a success story for the province. It's a high value crop, brings in lots of crop receipts. That adds to our GDP. And so we want to continue that momentum. So you can go back quite far in that initial table. I've chosen to start this data at 1980. And that's in part because that's when people really got serious about planting and harvesting canola. So I've got data from 1980 up until the most recent harvest year of 2022. And the first thing you'll want to do if you're trying to forecast is visualize what this data does over time. So we'll select all those options. You know how to do this. We'll go to recommended charts. I'm after a line chart. That one will do. Click OK. Let's make this a bit bigger. So as you look at that, the first couple things you're looking for is what's the nature of the data in the past? Is there a linear trend happening? Is there an exponential trend happening? Therefore, what model should I use for forecasting? And you can eyeball this and you can see, it does actually appear to be exponential. It really increases steadily and steeply in the more recent years. But you can also use Excel and some of the trend line options to help you figure this out. So if you go add chart element, trend line, click that, and then click on your trend line, click format trend line. You now have a linear trend on your sheet. And you can see even visually, there's quite a few points that are below that trend in these middle years and quite a few that are above in the later years. But you can get a little bit more scientific, and we know what R squared means. R squared is the equation for this line, and then, you can put the equation for this line on, like you see there, and that tells you where the slope, how the slope is responding right here. So for every increase in X, we've got about 25,000 increase in Y on this trend line. And then our R squared tells us how well does this trend line fit to the observed data. How much variance in Y is explained by this linear regression model. So let's go back here. We see it's 81%. Now, if I re-click on my trend line, I'm back over here in format options. I can pick and see, well, what does an exponential line look like? And visually, I can see there are fewer points further from this line. And lo and behold, my R squared value has increased from 0.81 to 0.87. So I'm explaining 87% of the variance in canola production now with this exponential model, which is an improvement. So that would signal to me that I should probably use some form of exponential forecasting to try and predict future dates. However, I will show you right now a simple way to do a linear forecast, because you may end up in another policy application or another scenario where linear is sufficient. And one way you can have Excel quickly do a linear forecast for you is to do exactly what we've done to date. We add a linear trend line. And then if you look at the format trend line options, there actually is a forecast option right here on the trend line. So we wanted to know, what's that value likely to be 10 years from now in 2032? If we want to use this linear model, simple, we add 10, we hit enter, and now it has extended my chart out to 2032. And I can kind of eyeball that figure there, and it's going to put me, if this was a linear trend, just above 12 million metric tons in canola production. So that may be what our forecasted value is. And then let's say, for back to our policy example, we want to set a goal and we go, well, that's just kind of status quo. We want to see even more canola production. Maybe we put that value up here at 14 million metric tons and say, in the next 10 years, can we drive that even higher than expected if we maintain the status quo? The struggle, or the bit I do not like about going this option in order to develop your forecast, is that it's giving you very specific numbers. And remember, forecast, there's no certainty. I would much prefer if this was providing me a set of range values. So there's some complicated math you could do to do a ton of extra steps if you have a linear model to calculate kind of that upper lower range in your forecast. I'm going to show you a simpler way to do it, but you can't do it with Excel if you have a linear trend, but you can do it if you have an exponential trend, which in fact we had. So how to do that? Highlight all of your data again. And now you can go click on data on the top ribbon, and you can click forecast sheet. And this is going to pop up a window and it's going to tell you, hey, Excel wants to use your historical data to create a visual forecast worksheet. That sounds all well and good. I only want it to go to 2032. So that's what I tell the forecast to end. And here we are. I want it to calculate confidence intervals for me. I want those upper lower bounds. I'll use a regular 95% confidence interval. It's reading where's your timeline range, that's column A. Where's your values, that's column B. And if I hit create, Excel has now given me a easier sheet and a data table to help me understand and communicate the forecasted values. So here I can see the predicted value for 3032 is again around that 12 million metric ton point, but I've got an upper and lower band, which really should be driving my my estimations or my communication. So if senior leaders ask me, what do we think the canola production will be 10 years from now in 3032, instead of misleading in them and saying, well, it's going to be 12 million, and they take that number and run with it, you know, that can be helpful in certain contexts, but I'll probably start that conversation by saying, you know, I'm 95% certain it's going to be between 9 million and 15 million. And so if those are my estimates of, you know, if status quo, 95% certain it's going to fall in here, and we want to set a target, you know, our call to put that target around 15 million before seems pretty reasonable. So that is another way to do forecasting with kind of one click of a button in Excel, and it gives you much better visualization of the range of likely values rather than kind of misleading and giving you just one set of precision. If you want to know exactly any of those years, it produces this fantastic table for you here where your forecast value for each year is present. So for 2032, I've got that 12 million number. If I wanted to know what's it going to be just a few years from now in 2026, it's estimating it's going to be about 10.7 million. And again, it's giving me a range of values, which helps me communicate the uncertainty behind any forecast. So with that, I will leave you guys to your exercise 3 for lab 3. Thanks for watching.